Good morning to all. So today is the third class of the internship program of mine. So today we will discuss about the 32 kilowatt grid connected power plant which is designed in our campus. So first of all, let's have some introduction about that. So you know that what is solar technology or solar energy. This is the PV system uses solar panel made up of the photovoltaic materials. When sunlight falls on the photovoltaic materials, it generates electricity. The power from solar panel is stored in the battery, and the battery ensures clean power to the load at any time. The functions of the charge controllers are to stop charging the battery from the solar panel when the battery is in full charging mode, and stop powering the appliances when the battery is down. So this is the basic things about the charge controller. When the battery is full, then it will stop the charge. When the battery has no power, then automatically the charge control ensure that battery has no power, then automatically it will charge. So here, this is the diagram. Here you can see sun energy which falls on the solar panel. Then this will connect, this solar panel connects to array junction box, and this array junction box is connected to PCU or inverter, that is power conditioning unit. This power conditioning unit is connected to array junction box as well as the grid input, and here the battery bank is bidirectional. That means the battery at a time it charges from this solar panel through the PCU and delivers its power by the help of the PCU, and we will get the power from the PCU or the inverter to the loads. So this is the basic or fundamentals diagrams about the grid connected power system, solar power system. Then the advantages are easy to install, safe, clean and reliable, minimum maintenance, no fuel required, can be used for free, no electricity charges. So these are the components. These are the components which are actually installed or inside the microgrid systems. Solar components in the sense solar panels collected energy from the sun and turn solar energy into electricity. So it converts the photons or lights or packets of energy into electrons of direct current. Then it is the array junction box. So it is used to interconnect several solar arrays. MCB, that means miniature circuit breakers, is used for the protection. So the number of solar panels are connected in series and parallel to make a junction. So to configure this junction, we must have to use array junction box, and MCBs are also connected to them. Next to solar battery. So stores electrical energy, solar panels charge the battery during the day, and this power can be drawn upon in the evening time. Then power conditioning unit. So power conditioning unit or PCU is solar charge controller plus inverter plus one grid charger. So these three systems are combined to make a solar or power conditioning unit. It converts DC to AC. It is charged battery bank through either solar or grid. So one thing I can share here you about the power conditioning unit, that it works as per the condition. That means it has a operating switch. You can change manually. You can change manually from grid to solar from priority basis. If you select the switch priority basis from grid, then the batteries are or will charge from the grid. But if you select the priority basis, that is solar power, then it will first draw the energy from the solar power. And another important thing is that we should set the minimum current to charge the battery. So, as per your priority, if you choose grid first and then solar, at that time it will fetch the maximum current. Either the solar power receives the maximum current or the grid receives the maximum current. So at that time what happens? The maximum current will draw as the priority basis. Suppose it is a cloudy day and you choose the priority basis is from solar power. Though it is cloudy day and the generation is less, so what happens? At that time, it will check the current, maximum current from grid or from solar power. So from where the maximum current it will draw, it will choose that option. So it is known as, that's why it is known as the power conditioning unit. And then these are the module mounting structure. Actually, module mounting structure, it is the rooftop design. It is not the ground level. If it is ground level, then we can be able to design by this method. Then grid input protection box. Grid input protection box. This protection device has inbuilt surge protection device, SPD. SPDs are a powerful protection device, more about 20 kiloampere it can sustain, so that when a maximum current will drop from outside, suppose let's consider about the lightning. So at that time what will happen? If SPDs are not there, then our system will break. If SPDs are there, then it will sustain a 20 kiloampere of current. So I think maximum, minimum protection is 15 kiloampere for the surge protection devices. And the miniature circuit breakers are there that will automatically cut the circuit when there is a short circuit. So it can be able to protect the PCU from grid spikes and voltage fluctuation. If there is a spikes from the grid, then if there is a fluctuations from the input voltage, then it will protect our device. Next, energy needs for 16.25 kilowatt peak into two identical solar microgrid. As you know that it is 32.50 kilowatt peak power plant. So here we divide this plant into two rows. That is, one is 16.25 kilowatt peak and another is also 16.2 kilowatt peak. Because here there are 10 subs are there. I think that is 10 subs. We will see one by one the subs. So here, for a better performance, we divide it into two parts. And each and every part sustain energy of 16.25 kilowatt. So first, let us take the sub number 1, that is UMBC sub. And the timing is 9 a.m. to 8 p.m. That is almost all 11 hours working. So UMBC sub, it is one of the practical example. Suppose you are going to design some microgrid or some grid tie or some power plant, you must have to take the load details, power consumption, quantity of loads, time to run, and as well as some of the remarks you must have to do that. But it is much more important to calculate the consuming power as well as the number of appliances and the energy to be calculated by multiplying watt into hour. So this must be required for you. So here in sub number 1, the load details are microwave oven, that is 2000 watt, 1, and time to run, that is 0.25 hour. So one fridge is there, Omphed fridge, that is 160 watt, that runs 10 hour. Mixer 550, that consuming power, and that runs 0.5 hour. Aquaguard 20 watt, it runs 6 hour. Self-frost 260 watt, runs 10 hour. Ceiling fan 75 watt, 2 numbers up there, and it working 6 hours. LED lights 14 watt each, number of quantities 8, and time to run 3 hours. Mosquito repellent 40 watt, that is 4 hours running. Cadbury fridge 90 watt, 4 hours running. I am sorry. Cadbury fridge 90 watt and 10 hours running. And some of the popcorn machine actually not working at that time, automatic cooker not working at that time, but one warmer or steamer 660 watt, that watt the power is calculated but not working. Then another French fry machine also not working. So this is for sub number 1. So sub number 1, you know very well, that is Shining Restaurant, always you use that. So the timing is 12 p.m. to 3 p.m. and 7 p.m. to 10 p.m. So I am sorry, exactly that is. So the load details, wall mounted fans 55 watt, 6 number of there, 6 numbers are there, and approximately running time is 4 hours. Then Sony speakers 5-in-1 420 watt and 4 hours it is used. LED light 12 watt, 14 number of numbers are there, time running is 6 hours. Wi-Fi 40 watt, 24 hours. Counter fan 40 watt, 5 hours. Refrigerator 180 watt and runs 10 hours. Then weighing machine 5 watt and run 3 hours. Havells mixer 750 watt, 1 hour running. Repellent also 40 watt, 6 hour running. Refrigerator 320 watt, 10 hours running. Wall fan 55 hours, 6 watt running. LED light 12 hours, 4 number 3 hours running. CCTV 5 watt, 4 hours 24, 4 numbers 24 hour running. So you can mark here some appliances which you not known about the wattage consumption. CCTV 5 watt, then LED lights 12 watt. So some of these things you must have to keep in your mind. Split AC 1650 watt, 1650 watt, and that is 2 numbers are there. Then another Hitachi model, something like that, 1650, 2 numbers. Then existing fan 746 watt, 2 numbers and running 3 hours. So one medicine store is there, Ambigen medicine, LED bulb 7 watt, 5 numbers are there, 4 hours running. Stand fan 180 watt, 8 hours running. And old refrigerator is that is 80 watt and 10 hours running. Then Centurion Food and Variety Store, CCTV is there, fridge, then that say another fridge, Samsung fridge, microwave oven, ceiling fan, LED light, then Cadbury fridge. So this power consumption chronologically 750, 405, 134, 2075, 1490, and some of the time to run, that is 24 hours, 10 hours. So these are all the working hours. These are all the working hours. And why we calculate the time to run or time of running? Because when the power is multiplied by hour, then we will get the energy. Suppose here is a CCTV 5 watt, number of is 25, number is 5, so it is 25 watt into 24. So you can easily calculate what is the energy. Here 750 watt is freeze, and that is 1, and time 10 hours. So 750 into 10, 7500 kilowatt hour. So 7500 kilowatt hour means 7.5 unit consume per day. Per day 7.5 unit consume. So you can easily calculate the total power consumption and total hour running. Then you can multiply that power into hour. So you will get the kilowatt hour. As you know that 1 kilowatt hour equals to 1 unit, so that you can be able to easily calculate what is the unit consumption per day. So according to which you can calculate, or you can demonstrate about the grid, about the solar, how much unit we will save from the grid. Then family foods. So LED lights, ceiling fan, fridge, Samsung fridge, and all the things are there are mentioned. Then another is sub number 6, produce center. Produce center, in produce center mixture, Crompton mixture, LED tube light. Then Ma Durga Venture, LED light, CCTV, fridge, stand fan, ceiling fan, and all the powers are consumed calculated, and time of running also calculated. So another is signing Xerox shop. So Xerox shop has a photocopier machine 1200 watt, and a lamination 600 watt, LED bulb, computer is 110 watt. So this is all about the signing Xerox shop load consumption. Then OMSI foods. OMSI foods, LED light, small fan, one pedestal fan, one mixer. So in tiffin shop, only stand fan and LED bulbs. And in coffee center, one stand fan, LED bulb, and coffee machine is there. And air snacks. Pepsi fridge is there, quality fridge, Whirlpool fridge. So here you can see Pepsi fridge is 260 watt, quality fridge is 160, Whirlpool is 191, stand fan is 180, microwave oven is 2000. So somehow in our home, microwave oven is not 2000, it is 850, 750, something like this. But here the oven is large, so power consumption is 2000 watt. Then LED TV is somehow it is 30 watt, but in our home it is 20 or 25. Sound system 100, cooler is 300, then digital clock is 5 watt. So push cart is LED light only, 30 watt, 3 numbers, and running 4 hours in the evening. New shaded area, LED lights are there, fans, outdoor lights are also there. Then new shaded area to be planned, already designed, LED light 10 and fountain, that is 746 watt. So these are all about the total loads calculated, total number of loads, total hour used. So it is very easy to calculate. If you calculate in your home how many number of appliances are there, and what is the wattage consumption by them, and how much hour you will use that hour. So according to that calculation, you can view your electricity bill, that you can be able to know that how much load consume your home. That is the domestic load. So once upon a time I had told you in the class that how to calculate the loads. So according to that load, according to that use of that consumption load, you will be able to calculate the total energy consumption. So you know that 1 kilowatt hour equals to 1 unit. So that in a day, if you use 20 kilowatt hour, if you use 10 kilowatt hour, if you use 5 kilowatt hour, then you will consume 20 unit, 10 unit, 5 unit as per your requirements. So at the end of the month, you must have to multiply into 30, so that according to your unit consumption, you have to pay the bill according to the tariff of the OERC. So this is the basic criteria, basic thing about the calculation of the load. So wherever you go, whatever the systems may be, you must have to calculate the loads first, then number of loads, then time of consuming. It is the mandatory things to design whatever the system may be. It may be a microgrid system, it may be a 100% DC system, or it may be your hybrid system, whatever the system may be. It may be grid tie, it may be net metering, it may be gross metering, or it may be standalone system, whatever it may be. So load calculation is must there. So, so according to this load, now let's have a look. Let's have a look about the system components. So here maximum load that can be connected 11 kilowatt. How? Why? Because all the 12 subs we are divided into two parts. So total watt is 32 kilowatt. So 32 kilowatt is maximum. 1000 volt is maximum. So that we have to divide it into two parts. So one is for 11 kilowatt. That is maximum units of energy kilowatt hour uses per day. That is 37.3 unit. So I had told you just now how to calculate the units. How to calculate the units? Total hour multiplied by total load. So watt hour or kilowatt hour is nothing but the unit. So it is 37.3 unit. And system voltage is 240 volt. Why it is 240 volt? As you know that our domestic load is 240, 230 or 220. So that we should have to keep the system voltage is 240 volt. And another technical term behind that, why it is 240 volt, I will tell you just later. Then the products are solar module with mounting structure 16.25 kilowatt peak, solar battery with battery rack 400 ampere hour and 240 volt. So this 400 ampere hour and 240 watt, please keep in mind. I will tell you just after now. Solar power conditioning unit, that is PCU, that is single phase. Dear students, that is single phase. That is not the three phase system. That is single phase. So I have forgotten to tell you about that. The system is a single phase system, not a three phase system. So the PCU is 20 kilovolt ampere or 20 kilovolt in the sense that is, you can see the domestic inverter is somehow 750 kV, 1050 kV or 1500 kV. So according to that, the specification is 20 kilovolt ampere and 240 volt. And centralized metering solution with data logging facilities also there, one set. Safety equipments and protection unit also one set, and cable and consumables are also one set is there. So this is microgrid 1. So next is microgrid 2. Microgrid 2 is also exact same. So if it is not exactly same, then we cannot never be synchronized. We never be synchronized, because here is grid 1, that is 11 kilowatt, and you can see grid 2, that is 11 kilowatt. So that the two systems must be synchronized with each other. So if it is not synchronized, then we cannot be able to get the maximum efficiency here, right? So the total system capacity is 32.5 kilowatt peak. So this is the system. Okay. So now here you will get the total solution provided. Now let us have the look, the mathematical modeling, and how we connect solar panels to the strings or junction box or battery, or that appears to the load. So please watch it. So you can see here, this is for one system, that means 16.25. This is one system. 16.25 kilowatt peak solar microgrid, specification nominal voltage 20 volt and number of cells are 72 polycrystallines. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 number of solar panels are connected in series. Here you can see. So what is the calculation behind that? 10 number of solar panels. That means each panel has the specification 325 watt peak. So in 325 watt peak, the maximum current withstand by one panel, that is 8.82 ampere. So it is 8.82, it is 8.82, it is 8.82, 8.82, 8.82, 8.82, 8.82, 8.82, 8.82, and 8.82. So 10 panels connected in series, each are 24 volt. So when the cells are connected in series, then voltage is multiplied and current is the same. So total voltage for one array, that is 10 into 24, that is 240 volt. So maximum voltage you will get 240 volt. Next, it is also 240 volt, it is also 240 volt, it is also 240 volt, and it is also 240 volt. So 10 number of panels are connected in series. Here 10 number of panels are connected in series. 10 numbers connected in series, 10 connected in series, 10 connected in series. And all the 10 are connected parallel to 5 in out, 5 in, 1 out with SPD array junction box. So now you can calculate here, when 10 number of panels are connected in series, we will get 240 volt, and each panel has the maximum current withstand, that is 8.82 ampere. So now you will get 240 volt because all strings or all arrays are in parallel. So when they are connected in parallel, so the current should be multiplied. So each string or each array has the output current 8.82 ampere. So 1, 2, 3, 4, 5. So 8.82 multiplied by 5. So that you will get how much current? 8.82 into 5. That is 44.10 ampere current. 44.10 ampere current. So keep in mind 44.410 ampere current you will get, and 240 volt and 44.10 ampere current you will get. And so far as system voltage 1000 and operating temperature is minus 40 degree to 85 degree. If it is 85 degree, then your system will not destroy, it will work. So this is the panel specification, panel configurations, the output voltage and the output current. According to your load, you will get. And your system shows 240 volt. Before that, I had shown you. Again, just it is 240 volt, and it is sum of 400 ampere hour. I will calculate now. Why it is 400 ampere hour, I will calculate. Just watch it. So now, you will see the 5 in 1 out with SPD array junction box is connected to DCMCB. So one DCMCB is there. So from this DCMCB, we have to connect our output to solar power conditioning unit. This is the solar power conditioning unit which convert DC system or DC power to AC power. So it is 20 kilovolt ampere, 16 kilowatt, 240 volt DC, single phase in, single phase out. Have you seen, is it visible? This is 1 PS, means single phase in and single phase out. This is negative, this is positive. And here, this is grid. So from grid input, this is neutral and this is phase. 120 kA SPD is here. I had told you before that SPD must withstand 20 kiloampere. So 120 kiloampere SPD is here, and it is the SCMCB, which is also parallelly connected to the solar power conditioning unit. If you have some conditions here, then your battery will charge according to your condition. If it is from grid or if it is from solar power, then the solar power conditioning unit connected to central load meter. This is the central load meter. This is the central load meter. And these are also some of the meters which are connected for the shops. How much? So 1, 2, 3, 4, 5, 6, 7, 8 or 1, 2, 3, 4, 5, 6, 7, 8 you can see here. So each and every meter is dedicated to one shop. How much energy they have consumed and how much money they have to pay, we have to calculate from here. Now, from the PCU, so through the DC circuit breaker, it is the DC circuit breaker, we have to connect parallel as well as series. So you can see here 5, 5, 5, 5, 5. So 1, 2, 3, 4. That means you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these 20 batteries are connected in series. So can you tell me what is the voltage? If the 20 batteries are connected in series, then you will get 12 volt. 12 into 20. So it is 240 volt. So our system is 240 volt. So it is synchronized. Now, each and every battery has 200 ampere hour. So all are 200 ampere hour in the sense in this series, it will deliver 200 ampere hour. But when it is parallel, then it is 400 ampere hour. So 200, 200 parallel connected. So they will give 400 ampere hour output. So that now you can just recall our output current or maximum current from the panel is that 44.10. Here, this is 400 ampere hour. So as you know that minimum 1/10 of ampere hour, if the current is much more that, then your battery will charge, unless it will never charge. It will charge, but it will take the time. So it is 400 in the sense just 1/10, that is 40 ampere hour. And your system current is maximum current 44.10 ampere hour. So it is excess, so that your system will charge. Okay. So we are using here C10 series battery and 10 number of batteries here, 10 number of batteries here. So this is for one system. This is for one system. That means two systems are configured. So this is 16.25 kilowatt peak microgrid system. And this is for one. And another system, something exactly like that, is also connected in this power plant. So this is all about the microgrid design and specification in our campus. So my dear students, if it is anything else, doubt in your mind, you must have to ask me.